Hello everyone. In this video, let's go through some logistic regression code example. So before going into this video, I would like to request you something. So if you are liking my videos, please do consider subscribing so that I'll get motivated enough in order to make more quality content. Okay. So now let's go into this particular video. Here, if we carefully observe what we are doing, initially we are importing all the required libraries like NumPy, Pandas, Matplotlib, and then Seaborn. So these are some of the commonly used libraries. Those we are importing at the start. And then we are reading the social network ads.csv. So let's check this particular social network ads. In this, the first column is user ID, which is not at all an important column because it will be some unique number for each and every row, right? So such columns are not at all needed. So there is no need for us to load that particular feature or column. That's why we can ignore this and we can only select gender, age, estimated salary and purchase. But in order to identify whether the person will purchase or not, I think age and estimated salary are good enough. So that's why for now I'm ignoring these two columns and I'm only moving forward with the remaining three columns, that is age, estimated salary and purchase. Okay, so based on age and estimated salary, I wanted to predict whether we'll purchase the specific product or not. So this is the task at hand. And obviously here we have two class of outputs, right? One is purchased and the other one is not purchasing. So it will come under binary classification problem. And let's try to see how we can solve with the help of logistic regression using code. Okay, like we can check the initial 5 rows by using df.head. So df.head will be giving us the first 5 rows. So these are all our first 5 rows. And similarly, there is another method called as tail, which will be giving us the bottom 5 rows. And similarly, there is something called as sample, which will be giving us random 5 rows from the data set. Okay, so like this, you can understand by observing these data points. So this is about head, tail, and some random 5 points. And similarly, one thing like we have discussed various pre-processing techniques, right? First of all, we discussed about something called as missing values. So in order to check whether the data is having some missing values or not, we can simply use this particular thing, that is df.isNull.sum. This isNull will be filling with true wherever there is some missing value. And what sum will be doing? The sum will be finding number of trues in each of the column. Okay, simply you can think of it like that. So as it is giving 0, that means that there are no missing values in the whole of the data set. So there is no need for us to handle these missing values. Okay, and this thing we'll do every time. So we'll be putting our input columns in X, whereas we'll be keeping our output column, that is our purchased column, in Y. Okay, so and we are doing it like this. After that, if we check X dot shape, X will be having 400 points and we are having two inputs, right? That is two features. So that's why it is 400 cross 2. And in Y, we'll be having only the output one column, right? That's why it is 400. Okay. So like that, we are having X shape and then Y shape. And then what is the thing that we'll be doing in general? We'll be splitting our data. Okay. So we'll be splitting it randomly. So in order to do that, we can use something called a strain test split. So here we are passing our X, that is our input features, and then we are passing Y, that is our output or label, okay, label column. And then we are mentioning the test size to be 0.3. That means that 30% of the points will be going into the testing data set and remaining 70% will be going into the training data set. Okay. And then we are giving some random state, which will maintain the same split every time when we execute the code. Okay. In that way, it will help us. And now if you observe, after dividing it into 70 and 30%, in Xtrain we are having 280 points, whereas in Xtest we are having 120 points. Okay, so this is the like some random 280 points were selected from the whole of 400 points and were kept in Xtrain, and the remaining 120 were kept in Xtest. So like that, our data got splitted, and similarly, Ytrain and Ytest for the corresponding data points that we are having in Xtrain and Xtest. Okay, so this is our data and you can print this data and check it as well. So this is our Xtrain and this is our Xtest. Okay, and here if you observe, this is something like age and salary, right? So there is no need for us to do some encoding on it. So directly we can go for the other pre-processing technique, that is data scaling. we have seen what is data scaling, right? And why we need it. We need it because we can reduce the convergence time. That is the objective of this particular data scaling. So that's why we can apply this one. And what we can do is we can simply use something like standard scaler, which will help us in doing standardization. And in standardization, what we'll be doing, we'll try to make the mean to 0 and standard deviation to 1. So that is what we'll be doing over here. So from sklearn.preprocessing, we are importing the standard scaler, and then I am creating some object of it, and then I'm calling fit on the training data, and then transform on both training and testing data. So this is my xtrain after scaling. So before scaling, my xtrain used to look something like this age column is in between maybe 20 to 100, and salary is from some 20,000 to 1 lakh or 1,50,000. But now if you observe it, the scale of both of them is equal, which is in between some -3 to +3. Okay. So most probably all the values will be present between -3 to +3, and both are in the same scale. Like that, our data will get scaled down. Okay. And now it can converge faster. So this is the use of this data scaling, and this is our xtrain and xtest after applying scaling. Now, like applying logistic regression is really simple. So we have discussed, right, what is our hypothesis in case of logistic regression, and what is our loss function in case of logistic regression, and then what is our optimizer. All these things we have discussed. So if you don't know all these things, please refer to the previous videos. There you will understand what is our hypothesis, loss function, and optimizer. Okay. All these steps will be done within this linear regression method itself. So first we can create an object of it, and then we can fit it on the training data. So we are passing xtrain and ytrain to the fit, which learns on the training data, okay, and adjusts that S-shaped curve, that is sigmoid curve. And after adjusting, what we can do, we can predict the values. So in order to predict, we can simply pass the input data to this predict method. So on passing it, it will be predicting the corresponding output. So like that, we have passed here xtrain, and these are the predicted outputs on the training data, and we have passed xtest, and these are the predicted points on the testing data. So we can compare it like this. This is the columns ytrain, that means actual output, and this is the predicted output on the training data. And similarly here, we are having ytest and ytest predicted. So this is the actual output for the testing data, whereas this is the predicted output for the testing data. So there is something called a score. Here the score will be accuracy. And what is accuracy? Accuracy is nothing but total number of correctly classified points by whole points in the data set. If we are considering training data set, in training data set, what is the number of points that we are having? So here if you observe, there are 280 points, right? So in the denominator, we'll be having 280. Among these 280, how many are correctly predicted? Those many will be in the numerator. So like that, we'll be getting the score of this particular accuracy. So if you wanted to see the formula, I'll be quickly writing it down. Accuracy equal to denominator will be having total number of data points, and in the numerator we'll be having correctly predicted points. So this will be our accuracy formula. Here we'll be knowing what are the correctly predicted points, and in the numerator we'll be having the total number of data points. So in case of training data, we'll be having 280 points, and within this 280, how many are correctly predicted? That particular number will be having it in the numerator. So according to this, so what is the score that we are getting? We are getting 0.85, which means that our model is 85% accurate on the training data. And similarly, there is accuracy score, which is from sklearn.metrics, which will be doing the same, that is, which will be applying the same formula. So for that, what we'll be doing, we need to pass our actual output, and then we need to pass our predicted output. So if we are passing like this, then it will be calculating the accuracy. So just to show that, so the score that is given by this is accuracy. In order to show that, I am just doing this as well. And similarly, you can get the score on testing data as well. So on training data, we are getting 85% accuracy, whereas on testing data, we are getting 83% accuracy. So we can say it is some good model only, because 85 is some good, like 85% of accuracy is a good thing only. It's not like very bad. We can say it's okay kind of model. And here also we are getting the same score. So if you wanted to observe graphically, so here is the scatter plots. So this is our original training data. So here most of our blue points are there, and here most of our orange points are there. There is some mix as well. So in these blue points, there are some orange points, and in these orange points, there are some blue points, right? So like that, there is some mix within it. And if we see the predicted data, so our predicted data is like to this side all the points are in orange, whereas to this side all the points are in blue. But maybe in this boundary some of the points it might have missed, and the points which are on this region in blue, those it might have missed. That's why we are getting 85% accuracy. Okay? So that we can observe by individually checking it like this. And similarly, this is on testing data, it is actual outputs. Okay, so these blue points are the corresponding to class 0, and these orange points are corresponding to class 1, and there is some little overlap. But if we see after applying our logistic regression, like this, the data is getting divided. Okay, so to this side, everything it is showing it as orange, and to this side, everything it is showing it as blue. And here there might be some errors at the boundary. That's why we are getting this 83% accuracy. Okay. I think that's it for this video. I hope everything is clear in this particular video. If you have any doubts, you can comment down in the comment section. I'll be replying for those. And thank you everyone. Bye bye. See you in the next video.